Hi everybody, this video is on systems of equations and we are going to start by graphing. So before we start, we need to know what this means. What is a system of equations? Well, a system means you have two or more equations that we're going to graph on the same coordinate plane. So remember, our x-axis goes side to side and our y-axis goes up and down. And we can actually have more than two graphs on a line together, and we can actually make some shapes with it. So we can have like this and this and that, and then make a little triangle. Super fun, but not yet. We're going to just start with two equations. So there's a couple things that can happen when we graph our equations, our two equations on the same line. The first thing is what's going to happen most often is that they intersect, they cross. And this ordered pair as an x comma y is going to be our solution. We call this a consistent and independent system. Now we also have consistent systems that are actually dependent. And this is where the lines actually end up right on top of each other. And we'll see that in a couple examples. An inconsistent system is when they do not cross at all, and we call those parallel lines, and we'll have no solution. So let's look at the first example. So when we graph, it's easiest if we are in slope-intercept form, which is y equals mx plus b. M is our slope, and that tells us rise over run. So how much do we go up and down, and then how much do we go side to side? B is called our y-intercept, and that's where we cross the y-axis. So in order to get this first equation into y equals mx plus b into slope-intercept form, we are going to subtract 4x from both sides. We'll rearrange our formula a little bit. 5 and negative 4x are not like terms because 5 does not have a variable. So we can't actually combine these together, but we're just rearranging our formula. So this tells me that I have a y-intercept of 5 and a slope of negative 4. Negative 4 is really negative 4 over 1, which means I go down 4 to the right 1. So let's count it out. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And we're going to connect these in a nice straight line. There we go. Now, in the next example, to get y by itself, I actually have to divide by 3. I'm going to rearrange this a little bit. Y equals negative 12 over 3x plus 8 over 3. Well, we all know that 12 divided by 3 is 4, so negative 12 divided by 3 is negative 4. And 8/3 is actually 2 2/3 as a mixed number. That's helpful for graphing, or 2.6 repeating. So how I figured that out was I took your numerator, the top number, and I divided by the denominator, which is the bottom number. How many times does 3 go into 8? That would be 2. 2 times 3 is 6. Subtract 2 2/3. So I'm going to go to about 2 2/3, about there. And now I'm going to go down 4 to the right 1 again. 1, 2, 3, 4 to the right 1. 1, 2, 3, 4 to the right 1. And what you should see here, what you should notice, is that these lines are parallel. How do we see that? Well, their slopes are the same, but their y-intercepts are different. So this would be one of those, This would be one of those inconsistent systems where we would have no solution. Because when we're looking for a solution to a system, it means where they cross, and these do not cross. So this is also called an inconsistent system. All right, let's go to the next one. So these are already in slope-intercept form for us. So that makes it super easy to graph. So here at -10 is our y-intercept. So we go to our origin and we go down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And our slope right here is 2, which is really 2 over 1. So up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I'm just going to keep going a little bit because I'm really bad at connecting these. There we go. Okay. Now my other graph is -4x plus 8. So 8 is our y-intercept. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And then here's my slope of -4. So I'm going to go down 4 over 1, down 4 over 1, down 4 over 1. This is my solution right here, where I crossed. So that point where I crossed is the ordered pair. And I'll start at the origin. How many over? 1, 2, 3. And how many down? 1, 2, 3, 4. This is a consistent, independent. So let's look all the way up here. Consistent and independent because we had one solution. Okay, example 3. Got a lot more work to do on this one to get it into slope-intercept form. So I'm going to go over here and I'm going to work on getting that y by itself. Remember, I'm trying to get into y equals mx plus b. So I'm going to subtract 3x. And I'm going to divide by 9. Now, these fractions do simplify. -3 over 9 is -1/3, and 18 over 9 is 2. So I'm going to start here at 2, and I'm going to go down 1 over 3. 1, 2, 3. Down 1 over 3. 1, 2, 3. Up 1 to the left 3. Okay, I'm going to do the same thing with this other graph. So I'm going to get y by itself. Add x. Divide by -3. Now, a negative divided by a negative is a positive. And really, this is 1x over -3, so -1/3 x. So I'm here at 2 again. Whoop, there's our answer. There's our intersection point. Down 1 over 3. Down 1 over 3. What do you notice? It's the same exact line. So that's a consistent but dependent because they are the same exact line. And it's actually infinite solutions because it's constantly crossing. It's always on the same line. So you notice we have the same exact thing that we are graphing. Y equals -1/3 x plus 2. Y equals -1/3 x plus 2. Okay, check the next video for the last one, and then I'm going to show you how to put it into the calculator.